Share with your sister. All right, turn in your textbooks, page 449, and let's take a look at your homework. You had two rational equations to solve, number 14 and number 15 at the bottom of page 449. Also two word problems on page 447, word problems 1 and 2. We will take a look at those momentarily. Page 449, numbers 14, 15, word problems 1 and 2. All right. Bueno. Else to say bien, I guess. 1 and 2. Guten? Is that good in German? Guten? Anyway, that's like saying good morning, like Guten Morgen or something like that. Anyway. All right, page 449. We'll stick to English. I just have my own struggles there. Page 449, number 14. We hate fractions, right? Agreed? And so we get rid of fractions and multiply everything by the LCD. Now, number 14, I feel like we can look at it and in our head figure out the LCD without having to do all this other work. What's the LCD just looking at number 14, Maddie? Right, we can mentally figure a squared negative 6, that's a plus 4, a minus 4. We already have an a plus 4. We already have an a minus 4. Clearly, that's your LCD, right? So as I'm working this, again, I'm lazy. I'm trying to find ways to take shortcuts. If that's my LCD, then on the first problem, number 14, when I multiply by a plus 4, a minus 4, it's going to cancel with the a plus 4, a minus 4 that would have been in the denominator, correct? Had I factored. So everything would cancel, so all I'd be left with is the numerator, 3a squared plus 16. Make it sense? Now on the next one, the a plus 4 would cancel, but that would still leave me, class, with an... And thank you, Brecken, for paying attention and locking in with me. Remember we said the LCD is going to be a plus 4, a minus 4. If I cancel the a plus 4, I still have an a minus 4, which has to have a negative a distributed to it. And that was a possible spot where we could mess this up. So we should have got 3a squared plus 16. And when we distribute, what should have come next, Noah?
Negative a squared.
Positive 4a. Check your work. How many had the positive 4a like you were supposed to? How many had negative 4a like Noah had said at first? How many have no clue what problem we're on? You better have a clue what problem. All right. So, and then of course we have our equal sign. And then in the last fraction, Gavin, what's going to cancel, obviously? It's not on the board, Gavin. You're going to have to look in your book at number 14, the problem we've been going over for the past 2 minutes. If I've got the a minus 4 on the bottom, so obviously what's going to cancel? Gavin. What's the LCD, Gavin?
A positive 4 and negative 4.
All right, I'm going to write it down. Now, after the equal sign, Gavin, we have a 2a over a minus 4. Gavin, what cancels?
A minus 4.
Leaving us with what, Gavin?
A positive 4.
Which has to be multiplied by the...
2a.
So we get...
2a squared positive 18.
All right, now, what I take away from this, Gavin, I act exasperated, and maybe I shouldn't, actually. Maybe you need to see it. Maybe that's how your brain ticks. Maybe you can't visualize things in your head, and that's okay, right? That's not necessarily a problem, but at least we've identified it, so don't try to do too much in your head. Because as soon as you can see it, then you're automatic, right? So some people can do more in their head. I'm one of those. I can visualize things. I can picture things in my head really well. But if you can't, then by all means show the steps, right? Take the time to show the work, and that's fine. All right, at this point, I've got a 3a squared and a minus a squared. Class, we can combine those to get? 2a squared. We have a positive 4a that has no friends. We have a positive 16 with no friends. And of course, over here, we just have the 2a squared and the positive 8a. So again, let me backtrack and finish that thought because I was addressing Gavin. Let me address all of you. I want to push you to be able to do more in your head. But if you just can't, then go ahead and show the steps, okay? It would be better to show the step and get it than to try to do it in your head and screw it up, okay? That said, you can do it in your head. Man, I'm all about that. Get it done faster. But know your own limitations. All right, at this point, Brecken, what should we be thinking to speed up our work? Let's cancel away those 2a squares, and at the same time, let's also move over the as a to get, and so we end up getting a is equal to 4. However, look at number 14. There's 2 things a isn't allowed to be, class. 4 and negative 4. It says a equals 4, but a is not allowed to be 4. Class, what kind of root is this? Extraneous root. So what's my answer then? Just lost my only answer I had. No solution. It's like when the only girl who would ever go out with you dumps you, she's like, now what do I do? No girl's ever been willing to speak to me before, now she won't either. No solution. Sorry, buddy. All right, that's just a happy thought as we head toward Valentine's Day in the near future. All right. Also called Single Awareness Day. SAD for short. But anyway, number 14 is no solution. How many had no solution? Did you have a equals 4? You just forgot to verify that. Nope, not even that one. All right, let's move on to number 15. Tell you what, we will not try to do too much in our head here. Looking at that first denominator, how should we factor that, Maddie? And frankly, if you looked at the rest of the problem, you should already suspect it might be x minus 3x plus 2. Right? Now, it's not a guarantee it is just because those other things are there, but the way the book works, I mean, we kind of should have caught on to patterns by now. That's a good chance. That's the LCD. So if the LCD is, as Maddie says, x minus 3x plus 2, so that's how she said it was factored. If that's our LCD, which we all should be able to see, then we're going to take that LCD, we're going to multiply it. Okay, Gavin, for some redemption, now that we can see the problem, what am I going to be left with after stuff cancels away here? What's going to cancel?
Yeah, nothing.
Nothing's going to cancel?
Wait. Yeah. Well, I mean, all of it's going to cancel.
All of it's going to cancel. So I'm left with nothing to multiply. So what do I write down?
5x.
There we go. All right, coming to the next fraction. What's going to cancel here? Noah? But that leaves me still with an to multiply to get. Again, it's nice when you have a positive, you don't have to worry about changing signs. As we come to the last one here, Brecken, obviously what cancels. But that leaves me with. Good, the x negative 3 needs to be multiplied there by that x positive 1 to give me. There we go. All right, at this point, what should we do now, Maddie? I'm sorry? Good, move everything over to the right-hand side. Set it equal to 0. We see the x squared. There isn't another x squared to cancel it, unlike last time where the a squareds could cancel. And now I've got 2 different x's to move, man. I got a 5x and a 4x. So really, I'm moving 9x over as a... And I'm also moving a 1 and an 8, which means I'm really moving a 9 as a negative. So what do I write down? And at this point, need to go and factor that back to Gavin.
X negative x positive.
Okay, x negative, x positive. How are we going to split up the 12 here? There's 3 different ways to do it. 1 and 12, 2 and 6, 3 and 4.
1 and 12.
There's going to have to be 1 and 12. We don't use it very often. Check your outer inner real quick.
Positive 11, so change the sign.
All right, so change that to the positive 1 and a negative 12. And when I set both of those equal to 0, what 2 answers do I get?
12 and negative 1.
And again, we did multiply by variables. It's possible we added answers. We should go ahead and check. But for sake of time, we won't. They do end up checking out. But normally, you want to check and make sure. But we'll save some time because we've got a lot to get to here in a little bit. Questions on number 15? How many have those answers, first of all? You have those answers. Okay, just a couple of you. Questions? Yes?
I accidentally did 16.
Okay. Questions on this? All right. Turn back to page 447. Turn back to page 447. Wake up. I know it's a rainy day. Rather be in bed. Hardest time in the world getting Chloe out of bed this morning. Did not want to get up. I don't want to get up. But we are here, so let's wake up. Number 1. Go ahead and read number 1 for us if you would, Noah.
The sum of a fraction and its reciprocal is 13/6. Find the fraction.
All right, and now here, Noah, it says find the fraction. In the past, when we've had a problem that says find the fraction, there's 2 things we're looking for, right? A numerator and a denominator. But that's because it tells me stuff about the numerator and the denominator. This tells me nothing about a numerator and denominator. So when it says find the fraction, there's really just one thing I'm looking for, right? So we could call the whole fraction simply x, because I don't know what it is. So it says the sum, which means I'm going to class add 2 things together. I'm going to add something here and something here. Well, one of the things needs to be the fraction that I don't know. So we'll just call the fraction, like Noah said, class x. But we're supposed to take the sum of the fraction and its reciprocal. How would I show the reciprocal of my fraction?
Or no, x 1 over x.
1 over x. There we go. Hey, fourth tries the charm. Right? X and 1 over x. And if we add this fraction, I know x is going to come out to a fraction, and its reciprocal, 1 over x, is supposed to equal 13 over 6. And this is probably the best way to try to solve this, is to represent your fraction as x, which means when we solve, we're going to get a fractional answer, which isn't favorite, but it is what it is. We're expecting a fractional answer. Normally we expect whole numbers, not now. We're expecting a fractional answer, and this is our fraction. This is how we show the reciprocal. How many have this equation? Okay, good job, Maddie and Brecken. Excellent. You two, does it make sense now? So as we solve, let me come to you two check your work. Noah, I see fraction, I hate fraction, I once again, which of course is
6x.
And when I multiply everything by 6x, I get
6x squared positive 6x f6 equals 13x.
All right. Now what do I need to do, Gavin? 13x over is a negative to get 6x squared, negative 13x positive 6, putting it in descending order, setting it equal to 0. Now comes the fun part, the backwards FOIL. Probably want to split a 6x squared, Noah, into
3x and 2x.
probably 3x, 2x. Positive sign tells me, Gavin. They're both going to be the same. In this case, they're both going to be negative. And probably we want to split our 6 up, class. 2 and 3. Not 3 with a 3 and 2 with a 2, but 2 with a 3 and 3 with a 2. Checking the outer inner, does that check out, class? It does. So we set each of these to 0. I get 2 possible answers for x. My first possible answer for x is going to be, anyone? 2/3. The other answer for x is going to be 3/2. Now, if the fraction is 2/3, then we would say that the sum of a fraction and its reciprocal, class, is 13/6. Let's see if that's true. Well, obviously we'd have to get a common denominator, right? Change this to 4/6. Change this to 9/6. Top and bottom by 2, top and bottom by 3. Does that equal 13/6? So 2/3 checks out. The other possibility is that we have a 3/2. Well, the sum of a fraction, 3/2, and its reciprocal would be
2 and 3.
Yeah, you see where this is going, right? Well, those are the same 2 things, they're just reversed order. So yes, obviously it makes sense we have 2 possible answers. One of these would be the fraction, the other would be the reciprocal, so it really doesn't matter which of these is your fraction. How many got either 2/3 or 3/2 for your fraction? All right, so you both had the correct equation, solved it correctly. Gentlemen, does it make sense what we should have done here? Let's take a look at number 2. Read this one for us if you would. Brecken.
The sum of the reciprocals of 2 consecutive integers is 5, 6. Find the integer.
Now, I'm representing 2 consecutive integers. How do I represent consecutive integers? Good, x and x plus 1. But notice it does not say that the sum of the integers is whatever. It says the sum of the reciprocals. Maddie, how would I set up this equation? Perfect. How many had this equation? 1 over x, the reciprocal of the first integer, plus 1 over x plus 1, the reciprocal of the second, equals 5, 6. Nobody but Maddie? You have that? You didn't have it, but you have it down. All of you at your seats rework it. All of you at your seats rework it then. By the way, did you notice on the previous problem there were 2 answers because it was a quadratic? Anytime your word problem involves quadratic, you could have 2 sets of answers. All right, for sake of time, check your work. Did you multiply everything by 6x, x plus 1? Did you end up canceling away, of course, as you went to get 6x plus 6 plus 6x equals 5x squared plus 5x? Did you then set it equal to 0 because it's a quadratic to get 5x squared minus 7x minus 6, thereby factoring and getting 2 possible answers, -3/5 and 2. Now here's the saving grace here. It's a quadratic. You might get 2 answers, right? Except for one little detail in the original problem. The sum of the reciprocals of 2 consecutive integers. One of those answers isn't an integer. You remember what an integer is? A nice, easy number. One of those ain't nice and easy. That answer is extraneous because it doesn't satisfy the conditions of the word problem. So my only answer is 2. And the next consecutive integer, let's check. The sum of the reciprocals. What would be the reciprocals, class? The reciprocal of 2 and the reciprocal of 3. There we go. So the sum of the reciprocals is 5, 6. Is that true or false? Well, this becomes 3, 6. This becomes 2, 6. Is the sum of the reciprocals 5, 6? Yep. So your answers are 2 and 3. That's what we should have had for number 2 in the homework. I can tell if you did that bad on the homework or if you're just that sleepy today. Questions? Go get out some graph paper. Let's review some things we talked about yesterday with graphing. Graphing involves two crisscrossing lines, two perpendicular lines. We call these lines, these number lines, class. Axes. Good, Brecken. You get to stay seated. The rest of you stand up. Two crisscrossing lines called axes, right? They're just number lines, right? So the vertical number line, the rest of y'all stand up. The vertical number line, class, is the... Oh, they all have to stay standing. All right, because Brecken got it again. The horizontal line is the...
Axis.
All right, they get to stay standing. Okay, now let them have a chance to answer there, Brecken, but I appreciate your enthusiasm and your evil intentions. All right. Now this horizontal number line, this x-axis, of course, we put arrowheads on the ends of it because we know that this end goes off to
Infinity.
infinity. You can have a seat. The other end goes off to negative infinity. You get to have a seat. And of course, we would label this end, the positive infinity end, with an x. Very good. All right, of course, the vertical number line we already said is the y-axis, and we'll label that with y, little arrowhead thingies. Now, I told you that these two crisscrossing lines cross each other at their zeros. We call this point, class, the origin. And from the 0, it goes up to infinity, down to negative infinity. But I told you, we're not going to label every single box because I'm lazy. So instead, I told you that the magic number for least amount of writing and easiest ability to read the graph is 3. That's your magic number. Are we going to label above or below the x-axis? Always a horizontal number line, you always go below. So we're going to go over to 3, 6, 9, then over to negative 3, negative 6, negative 9. You just till you run out of room. On the vertical axis, I told you we're going to go to the right or to the left? To the left. Okay, so we're going to come to the left, 3, 6, 9. And the reason we come to the left is because this section generally is where most of the graphing takes place. We want to keep that section clear. Now, there's 4 sections. We refer to these 4 sections, class, as quadrants. Good. And so this section where everything's positive, positive x's, positive y's, this section is the quadrant 1. Then down here,
Quadrant 4.
quadrant 4 up here,
2.
quadrant 2, and then here, quadrant 3. Good job. We're staying with me better now. That's good. And we said that every single point on this graphing surface, okay, has a specific location. We refer to the location of a point as that point's coordinates, right? Its exact location is called the coordinates. The coordinates are written in parentheses with the x value first, comma, and then the y value. Specifically, we refer to the x value of a point as the silent C. We're not kissing anybody. It's not approved here at Grace Christian School, except for teachers who are married, then they can. But anyway, abscissa, not abscissa, abscissa. Okay, so the abscissa. Say that with me, class. Abscissa would be the x value of a point. So, for instance, if I were to, I don't know, come right up here. Well, what is the abscissa of that point, class? Negative 3. It lines up with negative 3 on the x-axis. We also have a y value included in the coordinates. And what do we call the y value of the point? The ordinate. Okay, so co meaning with. When you put the abscissa with or co, the ordinate, that's what gives us coordinates. But the ordinate itself here would be, class, 7. It's just above the 6, which makes it easy to read. So negative 3, 7 would be the coordinates of that point. Because every point on this graphing surface has specific coordinates, sometimes this is referred to as the coordinate plane. However, it's also named after the guy who came up with it, so we also would refer to it in this class as the Cartesian plane, named after, do you remember the guy's name? Descartes, René Descartes, called the Cartesian plane. And yesterday we worked with plotting points. Well, today we're going to go a step further, right? Because if I were to plot some other point, let's just say this point, what are the coordinates of that point? Anyone? 7, 1. Good. We're over 7, and then we're up 1. So that would be the point 7, 1. Well, you know this. If I have 2 points, through 2 points, I can draw 1 straight line. And as far as graphing is concerned, a straight line is the easiest of all shapes to graph. So in Algebra 1, we're going to limit our discussion of graphing primarily to this discussion of straight lines. We refer to these straight line graphs, or rather the equations that will produce straight line graphs, as linear equations. So in your notes, if you go and write that term down, linear equations. There's a root word in linear. Do you see it? Line, right? Hence the reason for the name AR, that suffix refers to like or pertaining to. So these are equations that are like or pertaining to lines, equations that produce straight lines. A linear equation, write this down first of all, has both x and y in it. You have to have both letters because you're graphing x's and y's. X and y to the first power. We've seen equations with squares. We call those quadratic. But if x and y are to the first power, we would refer to that equation as a linear equation. I already referenced it, but if you'll jot this down, a linear equation is graphed as a straight line. Or since I went plural, I'll say straight lines. Linear equations are graphed as straight lines. And to graph linear equations, you need to, cross that out, put 3 points. Technically, you need 2. We're going to use a third point as a way of checking to make sure. For instance, if I'd also plotted this point, 2, 4, by noting that all 3 points line up perfectly, I'm convinced, yes, I graphed this equation correctly perhaps. So we're going to use 3 points instead of 2 to make sure that our graphs are done correctly. That leads then into the next section in your notes that we're going to work on for several days, okay? And that section is graphing linear equations. If I gave you an equation, you would want to produce a picture of the equation. That's all a graph is, right? It's a picture. So we're going to turn our equations into pictures. Boring pictures, yes. Okay, straight lines aren't particularly interesting, but pictures nonetheless. And we're going to graph linear equations by a few different methods. The first is the most basic. So under graphing linear equations, Roman numeral 1, graphing by table. Graphing by table. This is a method similar to what you would have used in the graphing sections of your pre-algebra work over the last year, 7th grade math, and even 5th and 6th grade math. As you worked with graphs, you'd be given a list of information, and you would have put it on your graph. Well, that's what we're going to do here. We're going to create a table that allows us to graph. If you're going to graph by table, first thing you want to do is to get either x or y by itself. You want to get x or y by itself. Get a letter by itself. We said that a linear equation, such as, for instance, 2x plus y equals 4, it has both x and y in it. We want to get one of those letters by itself. Well, which letter is easier to get by itself, do you think, Noah?
Y.
Notice the y is already a plain old y. Now, it's not by itself yet, though. What's with the y right now, class?
2x.
The 2x. But I can get rid of it if I just move it over, right? Easy enough. What does my equation look like then, Noah?
Y equals 2x, a negative 2x. That's 4.
All right, or you could put the negative 2x in and say 4 minus 2x. Either way would be fine. Y equals negative 2x plus 4. Notice the y is by itself. Now, a quick refresher for you. This is now what we would call a literal equation as well. Do you remember way back we talked about literal equations, equations with more than one letter? And we said that the letter that's by itself is called the dependent variable. Do you remember that term? Because the value of y depends on what you would plug in on the other side. So the letter by itself is the dependent variable. The letter not by itself, or letters, in this case just one, but the letter or letters not by itself, class, we would call the independent variable, because you can pick whatever you want to plug in for that letter or for those letters. And the numbers like negative 2 and 4 never change. We would refer to those values as constants. They're not variables at all, they are constants. Do you remember that? It's been a long time ago, so a little bit of a refresher for your memory. Well, what we're going to do, once we've gotten x or y by itself, and that's not hard to do, we're good at moving things around. That's one reason I teach it that way, is to make this step that much easier. We're going to set up an xy table. We're going to set up an xy table. This is the reason we call this method graphing by table, because we use a table to graph. Our XY table is a basic cheat chart. Okay? We put X's in one column, so we put Y in the next column. It is important that you put X in the first column, Y in the second, not the other way around. Because as we plot points, we want to be able to graph X then Y. We want to be able to plot our coordinates. So we set up an XY table. That's literally all there is to that step. Step number 3 is to plug in values for the independent variable. Plug in values for the independent variable. Remember, the whole premise of the independent variable is you can plug in whatever you want. That's what makes it independent. Well, the X here is the independent variable. So I get to pick values for the independent variable. Now, how many? Well, at least 3, because I want 3 points. So I'm going to need 3 X values. And let's let Gavin, I'm pointing right at you, Brecken, give us some X value.
1.
I like the way you think. All right, 1. I like it. It's a nice lazy number. Maddie, give me another number. 2. I like it. It's also a fairly lazy number. Gavin, 3. All right. Now, I will say I'm a little disappointed nobody said 0. Ah, yes, my laziness knows no bounds. I'm impressed by laziness of 1, 2, and 3, but I would have been more impressed by 0, 1, and 2. But I digress. There we go. There's some nice lazy numbers. And you just plug them in. Step number 4 is to find the dependent variable values. Find the DV values. So we plug them into the chart. We also have to plug them into the equation. So that's going to give me y is equal to negative 2 times 1 plus 4. Y equals negative 2 times 2 plus 4. Y equals negative 2 times 3 plus 4. We not only plug them onto the XY table, we also plug them into the equation. Make sense? Well, let's go with Brecken's value here. Negative 2 times 1 plus 4. Oh. Is negative 2 plus 4, 2. All right, Maddie, you picked 2. Negative 2 times 2 plus 4, 0. And Gavin, you picked 3. Negative 2 times 3 plus 4. What's negative 2 times 3?
6. Negative 6.
Negative 6. What's negative 6? Positive 4?
Negative.
Negative 2. All right. So we found our dependent variable values. Notice each one of these, if you were to put a comma and parentheses, is a point. So step number 5 is plot the points. If you would go and set up a coordinate plane or a Cartesian plane on your paper, you don't have to make it real big. You want to set up a Cartesian plane or a coordinate plane on your graph paper. I'll set up a fresh one here on the chalkboard with you. None of the numbers on our table are particularly large, so we don't have to make our graph particularly large. Again, mathematicians are lazy, doing as little work as they can get away with while still being right. More than laziness, mathematicians are obsessed with being right. But they want to be right the laziest, easiest way possible. Just so we're clear. All right, so once you've got your XY coordinate plane or Cartesian plane set up on your paper, go ahead and plot your points. We got a point 1, 2. We got a point 2, 0. And we have a point 3, negative 2. And plot those 3 points. And once you got those points plotted, you can probably figure out what we're going to do next. The goal is to get a straight line, right? What do you think we're going to do?
Draw a line.
Connect the dots. It's like going back to kindergarten. Connect the dots. What'd you do in school today? We played connect the dots. Paying how much for this education? Wow them with your fraction stuff. Make them feel better how much they're spending for you to learn how to play connect the dots. I would recommend a straight edge. Now, when you connect the dots, you want to make sure that your line goes all the way through both axes. They don't just simply connect the segment, but go all the way through. Some math texts would say you ought to put arrowheads at the end, because technically it's true. The line would go to infinity. I'm not necessarily particularly worried as long as the graph goes pretty much up to the top and pretty much down to the bottom. So draw the line all the way nice and through, nice and long. Let me come through and see how yours looks. All right, good. So bring a ruler with you to class. That would be highly recommended. If you don't have a ruler, you can certainly rent or buy one from me. I'm always looking to make some money. All right, now the first point was 1, 2. So this is over 1, this is up 2. And you still have the gluey stuff on the end of your pen. So 1, 2, 2, 0, 3, negative 2. You didn't notice they didn't all make a straight line? It's something like that. That's what we should have done right there. All right, let's go ahead and do another one of these. Write down this equation if you would, please. X minus 3y equals 1. X minus 3y equals 1. What's my first step? If I want to graph this linear equation, Noah?
Bring the negative 3y over to the other side.
Okay, because we're trying to do what here, Gavin? Could get one of the variables, x or y, by itself. So that would give me what if we did as Noah suggested? X equals 3y positive 1. Once we've got a letter by itself, the next thing we need to do, Maddie, is to set up the xy table. So go and do that at your seats as well. X column, then y. And we're always going to plug in values, class, for the independent variable. If you need to jot yourself a reminder, this is the letter that is not by itself. We're going to plug in values for the variable that is not by itself. And give me a value we can, which letter is that then, class, in this equation? What letter am I going to plug in values for in this equation, class?
Y.
Why? Because it's not by itself. So don't you write your numbers in the x column. You better put them in the y column, because that's where we're going to plug the numbers in. Give me a number, class.
0.
0. I like it. Thank you, Noah. 1. 2. I like it. All right. Well, if we plug in a 0, what do we get for x, anyone?
0.
1. 3 times 0 is 0, plus 1 is 1. Let's try this again for redemption. Gavin. If we plug in a 1, what do we get for x?
4.
4. There we go. Much better. And if we plug in a 2 for y, class, we get 7. There we go. Bracket. All right, using the same Cartesian plane you just had, if it was big enough. Now, we have to make it to the point 7, 2. If it's not big enough, draw another quick Cartesian plane. I'm going to cheat and use the same grid because I'm lazy. Plot your points 1, 0, 4, 1, and 7, 2. And then connect the dots. It should get a line that looks like that. Now, if you're in need of a straight edge, okay, and you don't happen to have a ruler readily available, you could take a piece of paper and fold it a few times to get a nice straight edge you could use. You could also use a corner of a binder or the edge of your textbook if it's not too damaged. Maybe repaired with shiny silver duct tape. That might be a little bit of a challenge to use. or you can just try to freehand best you can. But when quizzes and tests roll around, it'd be a really good idea to have a nice straight edge you can use. Hint, hint. Make sure we label X and Y axes. There we go, the artist in you coming out. Okay, go ahead and finish the line through there, Maddie, so that it comes all the way down toward the end of the graph, something along those lines, except straight, which mine wasn't, but yeah. Extending it through. All right, let's do one more. I'm going to write this one down. Y equals 2/3 X. Minus 1. Y equals 2/3 X minus 1. Now, ordinarily, Maddie, my first step would be to get a letter by itself, but observation, it's already done for you, right? So I can go straight to my next step, Brecken, which is to set up a little T chart, right? The XY table, where I'm going to be plugging in letters class for which or plugging in values for which variable class? The X, the one that is not by itself. Now we got to be smart here. I'm going to have to take 2/3 of whatever I plug in there. What's a number that's really easy to take 2/3 of?
6.
Okay, 6 is a number we could take 2/3 of easily. Another one?
4.
2/3 of 4 is going to be hard.
9.
Okay, I can take 2/3 of 9. Another one?
12.
12. Anything that's a multiple of 3, right? 3, 6, 9, 12. Anything you can cancel with the 3. How about 0? I like that a whole lot better than 12, because if I put a 12, that means my graph has to go out to 12. I don't want my graph to go out to 12. In fact, I don't even want my graph to go out to 9. But what's another number it's easy to divide by 3, to cancel with a 3? 3, very good. All right, so now technically you do have free choice in this, but since I'm lazy and I'm having to do it with you, I'm taking away your free choice. Now, if you're willing to draw your graph grid big enough to put a 9 and a 12 on there, more power to you. I ain't. All right, so let's start with a 0, because it doesn't get any easier than that. If I plug in a 0 here, class, 2/3 of 0 minus 1, negative 1 is my y value. Okay, now let's take 2/3 of 3.
1.
2 minus 1 would be 1. All right, now let's take 2/3 of 6.
3.
Right, cancel to get a 2, times 2 is 4, minus 1 is 3. Make sense? On the graph grid you just drew, because it should be big enough now, go and plot the point 6, 3. Go and plot the point 0, negative 1, and the point 3, 1. And I'm going to make this line dotted, so it'll stand out from the white and yellow lines that were previously drawn. This is, by the way, an exercise where if you have multiple colors of pens, I don't know if you're one of those, Maddie, a lot of girls like to have all different pretty colors of pens. You're not one of those. Okay, well, you're at a bit of a disadvantage there, because the girls who waste money on all the pretty colors of pens finally have a good use for them all. They can do all different lines on the same graph grid as long as they do them all in different colors. For those of you who are boring like me, since I didn't always have pretty colors, I always had a blue pen. I also had a black pen and a pencil. There you go, that's 3 different things. You could do dotted line and solid line if you want to stay using just pencil. But there's ways in which you can put multiple lines on the same graph and still have them be separate and distinct. And yes, that's because I'm lazy and don't want to have to draw a bunch of Cartesian planes. Do we feel like we got the idea on how to graph using a table? Feel like we got this? All right, set up a new Cartesian plane on your paper and do page 97, number 15. New Cartesian plane on your paper and do page 97, number 15. Get a letter by itself, set up the XY table, figure out which letter you're plugging in for, make sure you put it in the correct column on the table, plug them in to figure out the dependent variable, and then plot the points and connect the dots. Once you finish number 15, go on back and do number 14. Number 15 is on the board for you, so you can check your work. You don't have to use the same points I used, as long as your line looks the same as mine. Do you see why I used, instead of 0, 1, and 2, I deviated? Because I'm like, oh, that's going to give me negatives. But if I pick numbers bigger than 4, I can subtract more easily. Again, you don't have to do it that way, but it's an option. You just went the wrong way. Stay with me for just another minute. 1, -3. 2, -2. 3, -1. You just didn't account for the negatives. You're going up instead of down. So remember, the negative means you're going, oh, you had your negatives going up. Okay, negatives don't go up, negatives go down. Also, if you're going increments of 3, -3, -5 isn't consistent. Go just a little further and put your negative 6 there. Does that make sense? So don't go 3s and then 5s, but 3 to 6 as your next increment. Alright, let me show number 14 real quick. And the white line is what we should have for number 14. All right, your homework for this evening. Homework for this evening, page 97. Now I want you to notice how I wrote this up. Numbers 1 through 6, numbers 13 and 16, numbers 17 and 20. The reason I wrote it this way is we're going to have 1, 2, 3 different Cartesian planes on your paper. 1 through 6 are all going to have the same Cartesian plane. 13 and 16 are going to share the same Cartesian plane. 17 and 20 are going to share the same Cartesian plane. Does that make sense? So tomorrow I'm checking for 3 Cartesian planes with 1 through 6 on one, 13, 16 on the other, 17 and 20 on the other. All right, we'll look at all that tomorrow. Have a wonderful rest of your day, and we'll continue working on this in our next lesson.